All right, so this is 6.3, graphing sine and cosine functions. First, we're going to talk about what a periodic function is, because that's a really important part of being a sine and cosine function. A periodic function is a function for some real number. So here we're talking about alpha, that if you were to add that onto our x, it still equals our original f of x. So for each x in the domain. So what it means is that it repeats itself over some interval of time. A period is the least positive value for our fish here for this function. So pretty much what it's saying is how long it takes the function to complete one shift of it. So I have two functions here, and we're going to talk about the if it's periodic, yes or no, and what the period is. So here is my first function. Okay, so my function here goes up, down, up, down, up, down. You'll see the same up-down pattern is repeated, up, down, up, down. And the time it takes to go up and down before it does it again, that is in 4. So we would say, yes, it is periodic. And our period equals 4. Okay. So here's my next one. My next graph goes over, jumps up. So we have the same step function here. But this one's not periodic, because on this one over here, it's the same thing in the same place. If I were to cut this shape and put it on top of each other, it's a duplicate. But you'll notice right here, if I cut this shape and moved it over, it would not sit right on top, it would sit below it. So this one is no, it is not periodic, because it does not repeat the same thing over and over again. All right, so we're going to take a look now at our sine graph. Sine and cosine graphs are what we would call periodic functions, and it's because they repeat themselves over and over again. So we're going to use our unit circle to create our sine graph here. So right here on our sine, it is very specifically laid out this way. If you notice, our sine on our unit circle never gets bigger than 1. That is the biggest value of it. Okay, and it never gets smaller than -1. It always stays within there. So that's why our y values here are 1 and -1. Our x values are going to be the radian measure for which our sine values happen. So if I were to put in 0, I'm going to take a look at the sine of 0, and the sine of 0 is 0. So that point is right here on my graph. Now I'm going to take a look at the sine of pi over 2. So that's right here, pi over 2, the sine there is 1. Okay. So that means that all these other values here are sine, 1/2, root 2 over 2, root 3 over 2. Those are getting bigger as we get to 1. So those are these values in here as we get to 1. Okay, when we go back to pi, our sine is 0. 3 over 2, it is -1. And when we get back to 2 pi, that is the same as 0. If I were to then work backwards, so negative pi over 2 would be back here to -1. Okay, so negative pi over 2, that's -1. Negative pi would be 0. 3 pi over 2 is back up here at 1, and -2 pi is here. So you're starting to see here how my curve works. This is my sine curve. Okay. It is curvy. These are not points here. And you'll notice the periodicness of it. So it goes up, down, and back around and hits the 0 before it goes back up again. You see that here. It goes up, down, and around, up, down, and around. So that is our sine graph. It would then continue on. forever. Okay, so some interesting things about our sine graph here. Let's start with our, I'll write them down here. So my period for my sine graph, that happens in 2 pi units. So between 0 and 2 pi, that's how long it takes before it recycles again. Okay, the domain of my sine graph, my x's, it's gonna go on forever. So I'm gonna say that my domain is negative infinity to positive infinity because it's gonna go on forever in both directions. All right, now I'm gonna take a look at the range. Okay, the range is that we're gonna be greater than -1 or less than -1. So in my range here, I'm gonna say -1 to 1. That is where we fit within our range. Okay. Our y-intercept, actually, let's go with our x-intercept first. So where, I'll put it right here. Our x-intercept, that hits every time, looks like every unit of pi. So we're gonna say our x-intercept happens at pi n because it could be 0 pi's, 1 pi, 2 pi, -2 pi, so any number there. My y-intercept happens at 0, that's where it crosses. And then the last thing I need to look at is my min and my max. Okay, why these matter is because later on it's going to ask you what kind of curve do I have, and you need to be able to pick out reasons why it's what. So my minimum value here, this happens at a value at y equals -1. Okay, that's our minimum. And then how would I find that? Well, that's going to happen at every 3 pi over 2. 3 pi over 2 plus 2 pi n. So it's going to happen at every 3 pi over 2 or every period of 2 pi after that. My maximum happens at a 1. And that happens at every pi over 2, or it will happen again 2 pi after that. Okay. So that's our sine graph. You are able to graph your sine graphs in your calculators. Just be careful when you graph them. There's some special things you have to do with those. All right, so find sine of 9 pi over 2 by referring to the graph of the sine function. So we need to think of our sine function here, and we need to end up over here at 9 pi over 2. So I'm going to just sketch for myself. Let's see. Okay, I'll do it here. All right, and I'm going to sketch my curve. So it goes up, back down and around, up, back down and around, up, back down. And I don't know how many times I need to go up, down, and around. Right here, you'll notice that all these important points happen at pi over 2. So pi over 2 is the top. Here, this is pi over 2. This is 2 pi over 2, 3 pi over 2. So it's asking for 9 pi over 2, so I have to continue. So every important part is going to be pi over 2. So I got pi over 2 here. This one is going to be 2 pi over 2. This is going to be 3 of them. Here is 4 of them, 5, 6, 7, 8, 9, and my 9 pi over 2 ends up here at 1. Okay. So right up here, this would be where my 9 pi over 2 happens, up here at 1. All right, if I didn't want to draw that out, if I had some outrageous number, how could I find what that is? So I'm going to write the sine of 9 pi over 2 equals 1 from here. This is what I figured out. All right, so let's take a look at that. Well, I know that with our pi over 2's, that repeats every 2 pi. I could find those units of 2 pi and take those away, or I could find those units of just pi even and take those away to figure out where I end up here. So if I take a look at my 9 pi over 2, my closest whole number there I could take out of it is I could say that 8 pi plus 1 more is equal to 9 pi over 2. Well, 8 pi right here, this is the equivalent of 4 pi. And we know that that is the equivalent of 2 periods because our period is 2 pi. So that means that we're going to do our function 2 times and then add a pi over 2 to it. Well, at pi over 2, we know that that is a maximum. So right here, that is where our maximum would come from. So another way to see it is we would be looking at the sine of 4 pi plus the sine of pi over 2. Well, we know the sine of 4 pi, okay, units of pi are 0, and a pi over 2 is going to be 1. It's our maximum, so that would be our answer there. So some different ways to take a look at that. Okay, the next one says, find the value of theta for which sine of theta equals 0 is true. Okay, well, let's take a look at our graph up here. Well, when is our sine going to be 0? That happens at all of our pi's, okay? So we know that's going to happen at pi n when n equals any integer, right? That might be different for a different graph, but for this one, 0 is going to happen every time it crosses. We technically wrote that as our x-intercept. All right, let's go on to page 2. So page 2, we're going to look here. This says graph y equals sine of x between 3 pi and 5 pi. So let's take a look at what that sine graph is going to look like. Okay. We're going to start off with our exact same axis here. Okay. And I'm going to go across, and I'm going to give myself a little bit of space. So I'm going to say this one up here is 1, this one is -1, so I can kind of blow my graph up a little bit. Okay, I do not want my graph to start until I get to 3 pi, so I shouldn't have actually drawn my line in there, but I'm going to give myself this little squiggle because this is saying there is stuff before this. I am not starting my graph at 0, okay? I'm actually going to start my graph at 3 pi, and that's what I need to take a look at to be important. If you look at your sine graph, you'll notice that it goes in increments of a half. So for example, right here, this is another way of saying 0.5, 1, 1.5, 2. So on my graph here, I need to go in units of 0.5 pi. So I'm going to call this one, I'll skip 2. So I'll say that this is 3.5 pi right here. That means this one here is 4 pi. This here is 4.5 pi. This one is 5 pi, and that's what it asked for. Okay, so now I got to figure out at 3 pi, what part of my graph it's going to be at. Well, I know that any unit of pi will be at 0, so I know that part starts right there. Then I need to figure out from my 0, are we going to go up or down? Well, we got to think of our sine graph here. Right here, this is going to probably help us. This is an odd number of pi. So what happens? I'm at 0, 1 pi, 2 pi. This is my odd number of pi, and we head down. So that's where I'm going to head on here. So I'm going to go down to here, back up, and then I'm going to go back up and back down. And that is going to be what my curve is going to look like for there. If your starting point was going to be at 8 pi, we know an even number of pi is when it goes up and back around. So you just have to be thoughtful as you're making your graph. Our next graph we're going to take a look at is our cosine graph. So this one's going to be a little bit different. Okay. Our cosine graph just looks different than our sine graph does, and we're going to use our unit circle once again. If I were to take a look at where we're at 0, this one starts at a point of 1. So I need to make my my max and my min. So I'm going to go 1 and -1. But at 0 for this one, it is at 1. If I were to go to pi over 2, I'm at 0. And pi, I'm at -1. Okay, and then because we know this is, our curve is periodic, we can finish off our curve with our pattern of up, down, and around. So I'm going to draw in my cosine here. Like that. So our cosine graph here, this is what it looks like. We start up at the top, we go down and back around. So this cosine one kind of looks like a V, but if you take everything and show it, it is still just our sine curve. It's our sine curve shifted over in a different direction. So let's look at these things of our cosine graph and write them down. So my first thing here is my period. So my period here, for it to get back to the top, it goes down, up, and around, and it still ends at 2 pi, which makes sense because our unit circle is the same distance around. So our next one I'm going to take a look at is my domain. So what are the x values for this? Okay, x values go from -infinity to +infinity. Whoops, I wrote this wrong on the other page. Our range is going to be our x and y. So we go from, that's a bracket because it includes it, -1 to 1. Whoop, that's a 1 right there. Okay, our next thing I need to take a look at is my x and y intercept. So I'm going to look at my x-intercept. My x-intercept happens, oh, this one's different. It happens at every pi over 2 units. So we're going to say pi over 2 plus, it looks like every pi after that. Okay. My y-intercept on this one happens up here at 1. Okay. My maximum for my function here is going to be y equals 1. And the maximum, how I find that every time, is the maximum happens at every 2 pi units, so even units. So what we're going to call this is pi n. N is an even number. Okay, and if I take a look at my min is -1, and that happens at pi n, but n is an odd number. Okay, last one. So it says determine whether the graph represents a sine, a cosine, or neither. Okay, so this is really important, what I was talking about earlier. Taking a look at these pieces to figure out what is going on here, why we wrote these things down. So right here, this is our squiggle here, so that doesn't tell us any information there. I noticed that on my graph here, I am at my maximum. Okay, I am at my maximum at a even number. And I am at my minimum at an odd number. All right, so I could take a look at that. My min and max here are happening at 3 pi over 2, pi over 2. Right here, they happen at an even and an odd number. So that may be a hint for you that, yeah, this actually does make sense, that this one is going to be a cosine function. And so indeed, this one is a cosine, okay? Taking a look at where it crosses the x-axis would also be helpful. Although our x-axis is here, happen at pi over 2s, and at these it happens at units of pi, those units of pi, and this does not. So that would be another hint for you, that maybe you have a cosine because of those x-axis crossovers. All right, enjoy your periodic functions.